In this video, we are going to start with question 1. We are going to start with question 1. Okay, and without wasting any time, we will begin with question 1.1. In question 1.1, we are told that Pinda went to the shops to buy groceries. She checked the odometer of her car before driving. The reading on her odometer was 123,456 as indicated alongside. So we are even shown the odometer on the right hand side as well. Okay, so now we are told to study the information above and use it to answer the following questions. So the first question will be question 1.1.1. So question 1.1.1 says that choose the letter of the answer that will complete the following statement. The odometer is an instrument used to measure. So it is an instrument used to measure B, which is the distance. The distance. So it measures the distance that the car has traveled since it was bought. So this is the total distance that the car has traveled since it was bought. Okay. So now let's move to the next question, which is question 1.2, 1.1.2. 1.1.2. So question 1.1.2 says that express the reading on the odometer in words. What does that mean? So that means that we need to write 123,456 in words. So it will be 123,000 456. And that's our answer in words. So now let's move to the next set of questions, which are question 1.2. 1.2. So we are told that Pinda bought the following ingredients to prepare a ginger drink. So she bought 25 grams of ginger powder and 12.5 grams of tartaric acid and 1 kg of brown sugar and a bucket with a capacity of 10,000 centimeter cube. And this drink serves 40 people. And we're also told that 1 teaspoon is equals to 5 grams and 1 liter is equals to 1,000 centimeters. Okay, so now let's go ahead and work on our set of questions. So the first question will be question 1.2.1. So question 1.2.1 says that define the term capacity in this context. So capacity in this context would be the amount of space. Amount of space in a bucket. In a bucket that can be filled with ginger drink. So it will be the amount of space in a bucket that can be filled with ginger drink. Ginger drink. Okay, and now let's move to the next question, which is question 1.2.2. 1.2.2. So question 1.2.2 says that express ginger to tartaric acid as a simplified ratio. So once we see the word 2 and the question is asking us to get the ratio, we just know that this 2 refers to our 2 dots. So this will be our 2 dots that we are going to use. So in this case, we are told to express ginger. So our answer needs to be ginger and then 2. So the 2 is our 2 dot to tartaric. Okay, so if we look at our information, we can see that ginger was 25 grams. So we will come and say 25 is to tartaric, which was 12.5. 12.5. Okay, so in this case, we are asked to write our ratio in a simplified form. And what does that mean? So that means that we need to find a common factor. We need to find a common factor. And the common factor in this case would be 12.5. 12.5 because if we take 12.5 and multiply by 2, we will get 25, meaning that 12.5 is a factor of 25. And if we take 12.5 and multiply by 1, we will get 12.5, and that means that 12.5 is also a common factor of 12.5. That's why we are dividing by 12.5. So we need a number that if we divide using 8 on both sides, we will get a simplified answer. Okay, so what we do on our left hand side, we also need to do it on our right hand side, meaning that we are also going to divide by 12.5. So 12.5 divided by 12.5, just remember that any number divided by itself, the answer will always be 1. Okay, I was just fetching my calculator, and then now 25 divided by 12.5, that should be 2, but let's work it out. So it's 25 divided by 12.5. The answer is 2. So this is our ratio in a simplified form. Okay, so now let's move to the next question, which is question 1.2.3. But before doing that, we can just create a bit of space. Don't forget to like, share, and subscribe. And if you're not understanding something, you can just easily drop a comment, and then I'll be able to assist. Okay, so now let's move to the next question, which is question 1.2.3. 1.2.3. So question 1.2.3 says that how many teaspoons of tartaric acid are required to prepare the ginger drink? So we know that 1 teaspoon is equals to 5 grams, meaning that if we have 25 grams of ginger, we can just easily come and no, let's read the question again. Not ginger, tartaric. So the question says that how many teaspoons of tartaric acid? So we know that to prepare the drink, we need 12.5 grams of tartaric acid. So we are asked how many teaspoons of tartaric acid are required to prepare the ginger drink. So we know that 1 teaspoon is equals to 5 grams, meaning that to find the number of teaspoons, we just come and divide by 5 grams. Okay, so it will be 12.5 divided by 5, and the answer will be 2.5. So 2.5, 2.5 teaspoons are required to prepare the ginger drink. Okay, so now let's move to the next question, which is question 1.2.3. So question 4. Okay, so question 1.2.4 says that convert 10,000 centimeter cube to liters. And then if we look on our information, we can see that we are told that 1 liter is equals to 1,000 centimeter cube, meaning that to convert 10,000 centimeter cube to liters, we're just going to divide by 1,000. So we are going to say 10,000 divided by 1,000, and our answer will be in liters. So we will say 10,000 divided by 1,000, and our answer will be 10 liters. 10 liters. Okay, so now let's move to the next question, which is question 1.2.5. 1.2.5. So question 1.2.5 says that determine the amount of sugar that is required to prepare a ginger drink that can serve 200 people. Okay, so if we look on our information, we are told that we need 1 kg of brown sugar to prepare a drink that serves 40 people, meaning that if we want to determine the amount of sugar required to serve 200 people, we can just easily come and say 200 divided by 40, because we know that 1 kg serves 40 people. So if we divide the 200 people required now by the 40, we can be able to see the amount of sugar that is required to serve 200. So our answer will be 200 divided by 40, and it will be 5 kg. So 5 kg of rice, not rice, 5 kg of sugar is required to serve 500, to serve 200 people, because we are told that 1 kg serves 40 people. Okay, so we divided 200 by 40 so that we can be able to determine the amount of kg, the amount of sugar that is required to serve 200 people. Okay, so now let's move to our next set of questions, which is question 1.3. So question 1.3 says that Pinda lives in Edenvale and she visited her friend in Springs. She decided to use the national roads to travel to her house. Okay, and then the map she used for traveling is shown in Annexure A. Study the map in Annexure A and the information above to answer the questions that follows. So our first question will be question 1.3.1. So question 1.3.1 says that which national road or roads must she use from Edenvale to Springs? So if we look at the map and we look at Edenvale, we can see that from Edenvale to Springs, she will need to use the N3. So from Edenvale, she will join N3, and then just after passing, if you look at Johannesburg on the map, you can see that that's the N3. There's the N3 there, so it's written 3. And then if we look at, so maybe we can just show it even here. So here Springs. So here Springs. So there's the N3, that goes like this, and then it then comes this side. So here we have, so here is not Springs, this is Edenvale, and here is Springs. So this is the N3 and this is the N17. Okay, so there's this sign as well. There's this sign which stands for National Road. National Road. So if you look at the three is represented by this sign, meaning that it's the National Road. Even if you look at 17, it is also shown in this sign, meaning that it is also a national road. So the national roads that she can use will be N3 and N17. Okay, so now let's move to the next question, which is question 1.3.2. So question 1.3.2 says that, what is the general direction from Edenvale to Springs? Okay, so whenever you are asked to calculate the general direction, so we are asked that what is the general direction from Edenvale to Springs. So if this is Edenvale, okay, so this will be our map or our general direction that is going to guide us. Okay, so this will be north of this will be north of Edenvale, and this will be south of Edenvale, and then this would be east of Edenvale, and then here will be west of Edenvale. So if we are looking for the general direction of coming here, which is Springs, it would be this side, which is southeast of Edenvale. So it is southeast because it is between south and east, meaning that our answer would be southeast. So 1.3.2 would be southeast. So that's our answer. So now let's move to the final question for question 1, which is question 1.3.3. So question 1.3.3 says that, name the type of map represented in annexure A. So if we look at our map, we can see that this is a Johannesburg map because they show us Johannesburg and surrounding areas, meaning that it is a regional map. Regional map, and that will be our answer, and that will bring us to the end of question 1. In this video, we are going to start with question 2. We are going to start with question 2. Okay, so without wasting any time, let's jump straight to it. So we are going to start with question 2.1, and then we are told that Puseleto was invited to the University of Pretoria for an interview, and she used the map in annexure B to get to her destination. Study the map in annexure B and answer the questions that follows. So we are given a map in annexure B that we are going to use to answer the following set of questions. So without wasting any time, let's jump straight to question 2.1.2. So I will also attach the map on the right hand side of your screen so that you can be able to follow and see what's going on. So question 2.1.1 says that, how many provinces are represented on the map? So if we look at the map, we can see that on our far left we have Northwest, And then if we move south, we will see north. So we have northwest, and then we can also, if we move from, if we look south from northwest, we can see northern. We can see northern Cape, and then we can also see Free State, which is the east of Northern Cape. So there's Free State, and then if we move up, we'll see Gauteng, and then Limpopo, meaning that we have 1, 2, 3, 4, 5. Meaning that our answer will be 5 provinces. 5 provinces. Okay, so now let's move to our next question, which is question 2.1.2. 2.1.2. So question 2.1.2 says that which neighboring country is found on the western side of Limpopo? So if this is, so I'm just going to write the general direction again. So I'll keep writing it so that you also understand when asked about directions, where to look, right? So you should know this by head, because it will help you get so many marks that has to do with directions. So if we are in Limpopo, so this will be our Limpopo. So the question is saying which neighboring country is found on the western side of Limpopo. So this will be our western side, meaning that if we look at the map and we look at Limpopo, this will be Limpopo and this will be our western side. So if we look at the western side of Limpopo, we can see that there is Botswana. There is Botswana, meaning that our answer will have to be Botswana, because that's the neighboring country on the western side of Limpopo. So by neighboring country, it means that it's a country outside South Africa. It's another country. So it's outside South Africa. So it's another country in general, meaning that our answer will be Botswana. I hope that makes sense. Okay. So now let's move to the next question, which is question 2.1.3. 2.1.3. So question 2.1.3 says that identify the scale used in the map. So if we look on our map, we can see that we are given a scale which is something like this. So if you look down, you will see something similar to what I'm doing here. So this is our scale, and we can see that there are small bars within this scale. So we can say it's a bar scale, but we can also see that this scale is represented by a straight line, meaning that we can also say it's a linear scale. So whether you write bar scale or linear scale, you will still get it right. So we can either say it's a bar scale or it's a linear scale. Okay, so now let's move to the next question, which is question 2.1.4. 2.1.4. So question 2.1.4 says that give a set of directions that Puseletso should use when traveling from Vryburg to Pretoria. Okay, so if we look on our map, we can see that Vryburg is located on the N14, meaning that we can say that she can use if we look before getting into that, if we look on N14, we can see that it goes all the way to Gauteng. It goes all the way to Gauteng, meaning that she can use she can use the N14. She can use the N14 road, because the question says that give a set of, not just one, but a set of directions that Puseletso should use when traveling from Vryburg to Pretoria. Okay, and if we look again on our N14, we can see that there are 4 towns that are located on the road, meaning that she needs to make sure that she passes those 4 towns. So there's delay, I think it's Delareyville, and then there's Sannieshof, and then there's Coligny, and then there's Ventersdorp. Those are the 4 towns, meaning that she needs to pass 4 towns so that she can get to Pretoria. She needs to pass 4 towns, and those 4 towns are located on the N14. So if you look on the N14, you can see that there are 4 towns before she gets to Pretoria. So she needs to pass 4 towns. Okay, and then after passing the 4 towns, she will need to enter Gauteng province. So after Ventersdorp, there is Gauteng. So she will need to enter Gauteng. Remember, Pretoria is in Gauteng, so she needs to enter Gauteng. And then after entering Gauteng, she needs to realize that Pretoria is located just on the N1. So if we look at the N1, we can see that Pretoria is on the N1, besides the N1. So she needs to, or she will see that Pretoria will be situated on the N1. We can say Pretoria will be situated on the N1. Okay. So now let's move to our next question, which is question 2.1.5, but it's a bit lengthy, so let's create space first. And always remember, guys, that we do have extra classes that are very affordable. So our extra classes are 80 rands per month, and you attend you attend twice per week. Okay, so if you want to join our extra classes, just text the number that you are seeing on the screen. Just WhatsApp the number that you are seeing on the screen. Okay, so now let's move to question 2.1.5. Question 2.1.5. So question 2.1.5 says that Puseletso claimed that the actual distance that she will cover when traveling from Vryburg to Pretoria will be more than 450 kilometers. And then verify her claim by using the map and the scale to calculate the actual distance as the crow flies. Okay, so to calculate the actual distance, we will be guided by our scale. So our scale is equals to 2.5 centimeters. So if you take a ruler and you place it on our scale, our answer will be 2.5 centimeters. And then if you look at our scale, we can see that our scale represents 100 kilometers, meaning that if you travel 2.5 centimeter, it means that you have traveled 100 kilometers in real time. And then now we need to measure the distance from Vryburg to Pretoria. So if you place a ruler from Vryburg to Pretoria, you will see that the length will be 10.9 centimeters. meaning that to calculate the actual distance from Vryburg to Pretoria, we will use the actual distance formula. Actual distance, which will be, so this is the map length, and this is the bar scale length. So to get our actual distance, we will come and say map length divide by scale length multiplied by 100. So this 100 is coming from the bar scale, because we are told that if you travel 2.5 centimeters, not if you travel, we are told that if you travel 100 kilometers, it means that you have covered 2.5 centimeters. Okay, and then our actual distance would be our map length, which is 10.9 divided by 2.5 multiplied by 100. So our answer will be in kilometers. Okay, so if you are wondering where we got the 2.5 and the 10.9, so you just take your ruler, and if you take your ruler, just that I didn't print out this paper, I didn't get enough time to print out the paper, but if we take our ruler and we measure using the map that we are given, we will get these two distances, right? Yeah. Okay, so in this case we are going to say 10.9 divided by 2.5 multiplied by 100, and our answer will be 436 kilometers. So this is the total distance from Vryburg to Pretoria. And the question says that verify, so the question says that Puseletso claimed that the actual distance that she will cover when traveling from Vryburg to Pretoria will be more than 450 kilometers, and the total distance will only be 436 kilometers. So we can say that her claim is invalid. Her claim is invalid. Okay, so now let's move to the next set of questions. So we are going to move to the next set of questions, which is question 2.2. But before we do that, let's just create enough space so that we don't have to rub again. And if you're still making notes, you can just pause the video and make notes, and then after making your notes, you can then play the video again. Okay, so now let's move to question 2.2. So question 2.2 says that Puseletso left Pretoria at 1:30 in the afternoon, and she stopped twice, once for 10 minutes and again for 15 minutes to freshen up, and then she arrived in Vryburg at 15 minutes to 6. Okay, so we are going to start with question 2.2.1. So question 2.2.1 says that determine the average speed at which she was traveling in kilometers per hour, and then round off your answer to the nearest whole number. Okay, so we are also told that we may use the formula time is equals to distance divided by speed. So first of all, we need to understand how many hours it took Puseletso to travel from Pretoria to Vryburg. So we can see that she left Pretoria at 1:30. So we can just come and say, maybe let's just use a different marker. So she left Pretoria at 1:30. So we can just come and say 1:30. So this is the time that she left. Okay, so it's 1:30, and then we will have 2:30. So we are doing that so that we can calculate the total hours that she spent on the road. And then 3:30, and then 4:30, and then 5:30. So we can see that. And then from 5:30 to 17:45. So that's another additional 15 minutes. So we can say from 1:30 to 2:30, that's an hour. We can just say 1 hour. And then from 2:30 to 3:30, that's another 1 hour. From 3:30 to 4:30, that's another 1 hour. So that's another 1 hour on the road. Okay, and then from 4:30 to 5:30, that's another 1 hour. So we can see that it will be 1, 2, 3, 4. We can see that it will be 4 hours and 15 minutes. 4 hours and 15 minutes. So she traveled for 4 hours and 15 minutes. So the 15 minutes is coming from 5:30 to 5:45. So this is 15 minutes. Okay, but we are told that she stopped twice, once for 10 minutes and again for 15 minutes, meaning that from the 4 hour 15 minutes, we need to come and minus the 10 minutes that she stopped, and another 15 minutes. Okay, so we need to subtract 10 minutes and 15 minutes from the 4 hour 15 minutes. So if we subtract 15, we can see that we'll be left with 4 hours. So from the 4 hours, we need to come and subtract 10 minutes. And we know that an hour has 60 minutes, meaning that if we minus 10 minutes here, if we minus 10 minutes, it means that we are minusing 10 from the 60 minutes, 1 hour. So our answer will be 3 hours and 50 minutes. And that would be something like, so it will be something like 3. So it's 3.50. Okay, so it's 3 hours and 50 minutes. But we are told that we need to measure our answer in kilometers per hour. So now we need to convert the 50 minutes into hours. We need to convert 50 minutes into hours. And how do we do that? How do we do that? Okay. So to convert minutes to hours, we will just come and say 50 divided by 60. So this will be minutes. So we are converting the 50 minutes into hours, because we know that in an hour we have 60 minutes. That's why we are dividing by 60. So 50 divided by 60, we will have 0.83, meaning that we are now going to replace the 50 minutes by 0.83. So we will say So we will say the 3 hours plus 0.83. Okay, because we only took 50 minutes and we left the 3 hours because it is already in hours, meaning that in total we will have 3.03 plus 0.83, which will be 3.83 hours. So we can say it took 3.83 hours to travel from Pretoria to Vryburg. Okay, so now we need to use the formula that we are given on the question paper, which is equals to, remember we are calculating the time, so we'll come and say time equals to distance divided by speed. So here we calculated our speed, so our speed is in kilometers. It's in, so we are looking for the wait. So before we get to that, we are looking for the average speed. So here we got our time, so this is our time. So we are looking for the, so it's time, so this is our time in hours. So now we are looking for the average speed. Yeah, we are looking for the average speed. So our distance, so we know that if we go back to question 2.1.5, we can see that we calculated the kilometers, the distance that she traveled. So the distance was 436. So here we come and take the 436. Remember, she's traveling from Pretoria to Vryburg. So to travel from Pretoria to Vryburg, it takes 436 kilometers. So this is the distance from Vryburg to Pretoria. So the distance is 436 kilometers, and our speed is 3.83 hours, meaning that our answer will be, so we're just using the formula that we were given. Our answer will be 436 divided by 3.83. So it will be 113.8 kilometers per hour. So the average speed will be 113.8 kilometers per hour. And if we are rounding this off to the nearest whole number, our answer will be 114 kilometers per hour. I know this seems to be a bit complicated, but if you pause the video and rewatch it slowly, trying to understand where we are getting these numbers, you will see that it is very straight to the point, and you can easily get your full marks. So now let's move to the last question of question 2, which will be question 2.2.2. So question 2.2.2 says that name one a disadvantage of driving during the day. So we are told to name one disadvantage of driving during the day. So during the day, most people are driving, so there are likely to be more cars on the road. So an example, so an disadvantage would be traffic delays. So if more cars are on the road, it causes traffic, so there can be traffic delays. And that brings us to the end of question 2. In this video, we are going to start with question 3. We are going to start with question 3. Okay? So without wasting any time, we will start with question 3.1. So we are told that Tammy has a bakery and he supplies wedding and birthday cakes to local supermarkets. He was requested to bake a birthday cake with the following dimensions and specifications. So the cake that Tammy is going to bake has the top tier and the bottom tier, and the top tier has a diameter of 20 centimeter and a height of 15 centimeter, and it will be covered with icing except at the bottom. Okay, so the bottom tier has a radius of 12.5 centimeters, the height of 200 millimeters, and it will be covered with icing except for the bottom of the cake and the top surface area on which the top tier will be resting. So without wasting any time, let's just go ahead and answer our set of questions. So our first question will be question 3.1.1. So question 3.1.1 says that identify the shape of the top tier of the cake. We need to identify the top of the top tier of the cake. So we can see that our cake is represented in this form, and this is a circle. We can see that is a circle, meaning that our answer would easily be a cylinder. So the shape would be a cylinder. A cylinder, because we don't have a circle as a shape, so it's a cylinder. It's a cylinder. Okay, so now let's move to the next question, which is question 3.1.2. So question 3.1.2 says that convert the temperature required to bake this cake to F, which is Fahrenheit. So this is very straight to the point. So if we look at the information that we are given, we are told that the cake should be baked at 180 degrees Celsius. So we're just going to replace the 180 on our formula. So our answer will be F equals to degrees Celsius, which is 180, multiplied by 9/5 plus 32. So our answer will be, these are free marks, guys, these are free marks. So it will be 180 multiplied by 9 divided by 5 plus 32, and the answer will be 356. Okay, so now let's move to the next question, which is question 3.1.3. Question 3.1.3. So question 3.1.3 says that calculate the volume of the top tier. So we are going to calculate the volume of the cake on top. Okay, and we are also given the formula to do that. So our formula would be volume is equals to pi r squared multiplied by our height. So in this case, we can see that we are not given our r, which is our radius, but we are given our diameter, and we know that radius is equals to diameter divided by 2. Okay, meaning that our diameter in this case, it was 20 centimeters, meaning that our radius will be 20 divided by 2, and it will be equals to 10 centimeters, meaning that now we can be able to calculate our volume. So our volume will be pi. So pi is 3.142 multiplied by our r, which is 10. So it will be 10 squared, and then multiply again by our by our height, which is 15, So our volume will be 3.142 multiplied by 10 to the power 2 multiplied by 15. So our volume will be 4713 centimeter cube. So this will be our volume. Okay, so now let's move to our next question, which is question 3.1.4. But before we do that, let's create a bit of space. Let's create a bit of space. So we'll start with question 3.1.4. So question 3.1.4 says that determine the surface area of the bottom tier that will be covered with icing. You may use the following formula. So we need to calculate the surface area. So the surface area that we are going to calculate now, it is for the entire bottom cake that is covered with icing. It's for the entire bottom cake. So we are told that we can use the following formula, which is the surface area formula. So the formula is given: surface area is equals to pi r squared plus 2 pi r h, which is our height. So in this case, we can see that our height is given in millimeters, and if we want to convert from millimeters to centimeters, we just divide by 10. And some of you might be asking yourself that why are we converting our height into centimeters? So if we are calculating something, or if we are calculating the surface area of the volume, we need to measure them in the same way. So it's either we measure them in millimeters or we measure them in centimeters. But in this case, everything else was given in centimeters, so we can easily just convert our height into centimeters. So our height was 200 millimeters, so we'll just divide by 10 so that's how we convert from millimeters to centimeters. We divide by 10. Okay, so 200 divided by 10, our answer will be 20, meaning that our height will now be 20 centimeters. I hope that makes a lot of sense. Okay, so our formula, now we have our complete formula, and let's go ahead and calculate our surface area. So we know that our pi is 3.142, and then we will multiply by our r. So our radius was given for the bottom tier cake, which was 12.5 centimeters. So it will be multiplied by 12.5 to the power 2. So the 2 is on our formula. And then we have a plus sign here. So we'll come and say plus 2 multiplied by our pi, which is 3.142, and then multiplied by our r, which is 12.5, and then multiply by our height, which is 20. And then our surface area will be, it will be 3.142 multiplied by 12.5 to the power 2 plus 2 multiplied by 3.142 multiplied by 12.5 multiplied by 20, and our surface area will be 2061.9375. So this is our surface area, but this has icing. This includes icing everywhere on the surface. Okay, so it includes icing everywhere on the surface. But remember that the top tier cake bottom does not have icing. So it's basically like this. So this area here that has the top tier cake, it does not have icing, but here we calculated icing for everything on the surface. So now we need to remove this area that does not have icing. And how do we do that? We do that by removing the area of our top tier cake. So we need to find the area of our top tier. And how do we do that? Our area of our top tier would be pi multiplied by r squared, which is our radius. Okay, and now we'll come and say 3.14. so you need to know this formula of the area. So we'll come and say 3.142 because it was not given. So it's 3.142 multiplied by our radius, and our radius for the top tier was 10, so it will be 10 to the power 2, and then this will be equals to, so it's 3.142 multiplied by 10 to the power 2, so it will be 314.2. so we need to remove this. So our surface area will then be 2061.9375 minus 314.2. It will be 2061.9375 minus 314.2, and our answer will be 1747.7375. So this is our surface area of the bottom tier. So we have removed this part. So it's like we have removed icing on this part that does not have icing. Okay, so now we need to move to our next question, which is question 2.2. So now we need to move to question 2.2. So before we do that, we can just create a bit of space. Also, don't forget to like, share, and subscribe, guys, so that you can keep up to date with our maths literacy content. Okay, so now let's move to question 3.2. So question 3.2, we are told that after icing the cake, Tammy will put a ribbon around the top tier to decorate it, and the ribbon will overlap by 2.2 centimeters. Determine the length of the ribbon. So we need to determine the length of the ribbon, and we are also told that you may use the following formula. So we need to use the circumference formula. So remember this, the circumference. So let's say this is our cake. The circumference is the total distance around our cake, for instance. So it is the total distance around our cake. So we can use it to calculate to determine the, what is the question again? To determine the length of the ribbon. And we are also told that the ribbon overlapped by 2.2 centimeters. So it overlapped by 2.2 centimeters. Okay, so we are going to use the circumference formula. So we are going to use the circumference formula, which is equals to 2 pi r. And remember, we are told that we are only focusing on the top tier, on the top part of the cake. So our answer will be 2 multiplied by our pi, which is 3.142, multiplied by our radius, which is 10. So the radius of our top tier was 10. Okay, and our answer will be 2 multiplied by 3.142 multiplied by 10, and it will be 62.84. 62.84. And we are told that our ribbon overlapped by 2.2 centimeters, meaning that now we also need to account for the 2.2. We need to account for the 2.2. So we'll come and say 62.84 plus 2.2. And our answer will be, so it's 62.84 plus 2.2. So our answer will be 65.04 centimeters. And what does overlap mean? So remember, the circumference is the total distance around our cake, but the distance has an additional overlap or length of 2.2 centimeters. So besides it just being around the cake, it has an overlap of 2.2 that we also had to account for it, because here we are calculating the total distance of our ribbon. So our ribbon had an overlap of 2.2 besides the circumference that we just calculated. That's why we had to add 2.2. So I hope that makes sense. Okay, so now let's move to question 3.3. 3.3. So question 3.3 says that Tammy started baking the cake at 12 minutes to 8. 12 minutes to 8. And the cake was ready at the time displayed on the clock analog due to load shedding interruptions. And then now we are told to, so before we get to that, we are going to start with our first question, which is question 3.3.1. So question 3.3.1 says that express the time displayed on the clock in 24-hour format. So we can see that the small arrow pointing on our time will be pointing at 10. So the small one is pointing at 10, and meaning that our time will be 22, and the bigger one is also pointing at, so the bigger one is pointing at 2, which means 10 past. So it will be 10 past 10. Okay, so now let's move to our second question, which is question 3.3.2. Okay, so question 3.3.2 says that determine the time taken for the cake to be baked. Express your answer in hours. So we are told that Tammy started baking at 12 minutes to 8 and finished at 10 past 10. So if we calculate from 12 minutes to 8 to 10 past 10, we will see that Tammy took 2 hours and 22 and 22 minutes. 2 hours and 22 and 22 minutes. But the question said that determine or express your answers in hours. So the answer that we have here now is expressed in hours and minutes. And if you remember, we know that if you want to convert minutes into hours, we divide by 60. We divide by 60. So in this case, we are going to say 22 minutes, 22 divided by 60, because we know that in an hour we have 60 minutes. And if we 22 divided by 60, and if we divide, we will get something like 0.37, meaning that now we are going to add 2 plus 0.37, and our answer will be 2.37 hours. So now our answer is represented in hours. So we added 0.37 because we converted 22 minutes into hours. So this is where it is coming from. Okay, so now let's move to our next question for question 3, which is our last question for question 3, which is question 3.3.2. So question 3.3.2, question 3.3.3. Question 3.3.3 says that suggest an alternative source of power that can be used to beat load shedding. So it can be solar, or it can be, for instance, a generator. Yeah, and there can be other alternative sources as well. So this brings us to the end of question 3. In this video, we are going to start with question 4. In this video, we are going to start with question 4. So we will start with question 4.1. So question 4.1 says that Mr. Kekana, the sports organizer at Cyprian High School, planned a marathon for his soccer players. He shared the map shown in Annexure C with the participants. And the participants may choose to run a full marathon or a half marathon. The distance reflected on the map is in miles, and the elevation above sea level is in feet. Okay, so we are told to study the map in Annexure C and answer the questions that follows. And we are also told that 1 foot is equals to 12 inches and 1 inch is equals to 2.54 centimeters. And we are told again that 1 mile is equals to 5,280 feet and 1 foot is equals to 30.48 centimeters. So we are going to start with the first question, which is question 4.1.1. 4.1.1. So question 4.1.1 says that give one advantage of completing a half marathon. So if a person is completing a half marathon, an advantage would be to improve their confidence. Would be to improve confidence. To improve confidence. Okay, so now let's move to the next question, which is question 4.1.2. 4.1.2. So question 4.1.2 says that describe the trend of the graph from 14 miles to 26 miles. Okay, so we can see that from 14 to, so we can see that from 14 we can easily see that from 14 to 16 We can see from 14 to 16, the graph is decreasing. It's going down. So we can see it's decreasing, or it is downward trending. Okay, and from 16 to 17, we can see the graph is constant. It is not increasing, or it is not decreasing. It is constant. It is flat. And then from 17 to 23, we can see that the graph is increasing, which is another way of saying the graph is upward trending. Okay, and then from 23 to 26, we can see that the graph is decreasing. The graph is decreasing. And then now we are done with question 4.1.2, and let's move to question 4.1.3. 4.1.3. So question 4.1.3 says that determine the difference between the distance covered at the highest elevation and the end of a half marathon in meters. So the question is saying determine the difference between the distance covered at the highest elevation. So we can see that the highest elevation is on 8. Highest elevation is on 8 miles. And then the end of half marathon is on 13 miles. So we need to determine the difference between the two first. So the difference would be 13 minus 8. And 13 minus 8 will be equals to 5. So the difference would be 5. Okay, and we are told that we need to so determine the difference between the distance covered at the highest elevation and the end of a half marathon in meters. So this is given in miles. So we need to convert from miles to meters, and we need to use the information that we are given. So what we need to do first would be to convert miles to feet. So step 1 would be to convert miles to feet, and we are told that 1 mile is equals to 5,280 feet. So to convert 5 miles into feet, we'll then take our 5 miles and multiply by 5,280, and then we'll get our answer in feet. So our answer will be 5 multiplied by 5,280, and our answer will be 26,400. So 5 miles is equals to 26,400 feet, and we know that 1 foot is equals to 30.48. So to convert feet into centimeters, so step 2 would be to convert feet into centimeters. So because 1 foot is equals to 30.48, it means that we are going to multiply our feet by 30.48, and we'll get our answer in centimeters. So we'll come and say 26,400 multiplied by 30.48, and we'll get our answer in centimeters. So we'll multiply by 30.48, and our answer will be 804,678 centimeter. And remember guys, we know that it's very easy to convert from centimeter to meters. So we convert from centimeter to meters by just dividing by 100, meaning that our answer will be 804,672 divided by 100. And if we divide by 100, our answer will be in meters. So we just divide by 100, meaning that our answer will be 8046.72 meters. So this is our final answer. So we have converted from miles to meters, and that's how we did it. Okay, so now let's move to the next question, which is question 4.2. Now let's move to the next question, which is question 4.2. Okay, so we're just creating a bit of space so that we can be able to answer everything in a space that is enough. And don't forget guys that we do have extra classes, and if you wish to join our extra classes are just 80 rands per month. So you pay 80 rand and attend 2 times per week and 8 times in a month. Okay, so they are very affordable. And if you wish to join, you can just text the number you are seeing on the screen on WhatsApp, and then we will be able to add you to our group. And our extra classes are online. Okay, so now let's move to the next question, which is question 4.2. So question 4.2 says that Question 4.2 says that Mr. Kekana took the soccer players to the local clinic for health screening before the marathon. Study the growth chart in Annexure D and the health status table below to answer the questions that follows. So we are going to start with the first question, which is question 4.2.1. So question 4.2.1 says that how old is Jabulo, whose BMI of 19 kilograms per meter squared places him on the 50th percentile. So if we look at 4.2, which is our body mass index graph, we can see that we have different line graphs inside. We have different lines in the graph, and those lines are representing percentiles. So we can see that there are numbers. The first line is 3, the second one 10, the third one is 25, the fourth one 50, then 75, 85, 90, 95, and 97. Those are percentiles. And if we look at our y-axis, we can see that our y-axis is our BMI per kilograms. It's our BMI, body mass index, and it's given in kilograms per meter squared. So the first question is saying, how old is Njabulo, whose BMI is 19 kilogram per meter squared? So if we go, we need to go to our y-axis and on 19, and then on 19 we need to find the 50th percentile line. So we need to match that. So if we look at 19 and we check on our 50th percentile line, we can see that Njabulo is 14 years old. So we can see that Njabulo is 14 years old. So we need to see where the 19 kilogram per meter squared is meeting the 50 percentile line. So where they meet, that will be Njabulo's age, and they meet on 14. Remember that our x-axis represent the age. So if you check down there, you can see that it is age in years. So if you look at age 14, you will see that it's on 19 and the 50th percentile. Okay, meaning that Njabulo is 14 years old. So now let's move to the next question, which is question 4.2.2. Question 4.2.2. Okay, so question 4.2.2 says that 16-year-old John with a weight of 67 kilograms and a height of 120 centimeters claims that his weight status is healthy. So if we look on our table, we can see that the 5th to 85 percentile, between 5 and 85 percentile, this person would be happy. Not happy, would be healthy, by the way. Okay, so we are told that 16-year-old John with a weight of 67 kilograms and a height of 170 centimeter claims that his weight status is healthy. Verify his claim by showing all calculations. So we are given a formula. So first we need to find our BMI in this case, so that we can be able to check whether he is healthy or not. And our BMI is, so we can get our BMI using the formula that is provided, which is weight in kg divided by our height in meter squared. So if we check at John's height, it is given in centimeters, meaning that we need to convert it into meters, because we need to divide by height, but in meters. But the one that is given in centimeters. So how do we convert from centimeters to meters? So converting from centimeters to meters, we divide by 100. So we'll come and say 170 centimeter divided by 100. So here we are converting John's height, right? That's what we are doing here. So we'll come and say 170 divided by 100, and our answer will be 1.70 meters. Okay, so we can see 1.70, we can just see 1.7. So let's just see 1.7 because that's what the calculator gave us. And so that you don't be confused, right? Yes. Okay, so now let's move to our, let's go ahead and calculate. So our weight was given, so our weight is 67, so we'll come into 67 divide by our height of 1.7. Remember that our formula also include to the power 2, so we'll say 1.7 to the power 2, and then our answer will then be, so it will be 67 divided by, so it will be 67 divided by 1.7 to the power 2, and it will be 23.18. So we can say 23.18, or we can say 23.2. Still one and the same thing. So here we just rounded it off to one decimal place. Okay, so our answer will be our BMI. So now remember that John is claiming that he is healthy, right? And the person that is healthy needs to be between 5 and 85 percentile. Okay, so now we take this 23.3 to our graph and check where it falls. Okay, so if we check 23.2, So if we check 23.2, we can see that it is between 50 and 75. It's between 50 and 75. Let's check. Yeah, so it's between 50 and 75. And we know that for a person to be healthy needs to be between 5 and 85 percentile. So we can conclude that John is healthy. We can conclude that John is healthy. So you just check on the lines, on the percentile lines, on the graph that we are given. So what you need to do first, just that I was not able to print it out. So you need to go to 23.2 on your y-axis and then check where it is falling between those lines. You check where it is falling between those lines. So you can see that it is between 50 and the 75th percentile. And for a person to be healthy, he needs to be between 5 and 85 percentile. So we can conclude that John is actually healthy, by the way. Okay, so now let's move to question B. So this was question A for 4.2.2. So now let's move to B for question 4.2.2. So question B says that, what advice do you think the nurse will give to a soccer player with a BMI for age percentile of 86? So if a person has 86, so this person is on a risk of becoming overweight. So the nurse can advise the person to start exercising. The nurse can advise the person to start exercising. So that brings us to the end of question 4.2.2. And we'll be moving to our last set of question, which is question 4.3. So before we move to question 4.3, we can just create a bit of space. Okay. Don't forget to like and subscribe. Don't forget to like and subscribe so that when we upload, you will be the first to be notified. Okay, so now let's move to our last set of question, which is question 4.3. So question 4.3 says that the following options of drinks and snacks will be served at the refreshment stations. So drinks, we will have water, juice, and energy drinks. So water is represented by W, juice is represented by J, and energy drinks is represented by E. And then with snacks, banana is represented by B, and chocolate bar is represented by C. So we are told that the tree diagram of the refreshments has been drawn below. Okay, and the tree diagram of the refreshment has been drawn below, and study the tree diagram below to answer the questions that follows. So if we check on the first one, we can see that it is a combination of W and C, which means water and chocolate. And the second combination will be W and B, which means water and banana. So we can be able to find the missing values by just understanding those two. Okay, so the first question will be question 4.3.1. So question 4.3.1 says that complete the tree diagram by writing down the answers I and 1 and 2. So it's I and 2. So I, we can see that it is a combination of E and what? So we can see that it is a combination of E and C, meaning that our I will be C. And then the second one, it's a combination of G and C, meaning that our final answer should be JC. Okay, so now let's move to the next question, which is our final question. So our final question says that it will be question 4.3.2. So question 4.3.2 says that determine the probability of choosing a refreshment with juice and express your answer as a decimal number. So we need to express our answer as a decimal number. So we need to determine the probability. So always remember that when we are dealing with probabilities, we divide by total possible. We divide by our total possible answers. Total possible answers. So in this case, how many total possible answers do we have? So we can see that we have 1, 2, 3, 4, 5, 6. So those are our total possible. So we can say answers or outcome. So those are our total possible outcomes. So we have 6 possible outcomes. So we need to determine the probability of choosing a replacement with choose. So now on our total possible outcomes, we need to come and check the ones that have choose. So we can see that we have JB and we also have JC, the one that we calculated, meaning that there are 2 that has choose. So this will be our probability. But we are told to express our answer in a decimal number. So this is a fraction. So to convert this to decimal number, we just come and say 2 divided by 6 is equals to 1/3, which is 0.33. And this is our final answer. And that brings us to the end of question 4.